The last section of the chapter 5 is about the area between the curves. We found that the definite integral from a to b represents the sum of the signed area between the graph y equals f of x and the x-axis from the x equals a to x equals b. Why are we saying this signed area? Because f of x should be positive. I mean, this is the f of x. Here y equals f of x is the graph. So f of x is positive. So from a to b, so this area equals from a to b f of x dx. If f of x is negative, like this one, y equals f of x, here f of x is negative, so the area between the y equals f of x and the x-axis is this area. This area not equal to integral from a to b f of x dx, because function is always negative. So this is area of the minus 1 times area of the region. So minus the definite integral of f of x from a to b give us the area of this region. So because of this reason, we say signed area between the graph of the f of x and the x-axis from a to b, where the area above the x-axis are counted positively, like the first left side, this one, and the area below the x-axis are counted negatively. So this is negative. In this section, we are interested in using the definite integral to find the actual area between a curve and the x-axis, or actual area between the two curves. Okay, these areas are always non-negative quantities because area measure is never negative. So, area between the two curves. Let's calculate. Consider the area bounded by the y equals f of x y equals f of x, like this one, and y equals g of x, y equals g of x, where f of x is bigger than g of x. Okay, without loss of generality, we can assume this one. Actually, in the future, we will generalize. So for on the interval a to b, we assume f of x is g of x bigger than f of x bigger than g of x, and also all of them bigger than the 0. So here we assume that f of x bigger than g of x, and this bigger than 0. They can be equal to the other self, for which a, for the x between a to b. Okay, so this point is a, let's say this point is b. So we know from the a to b this fact. So the area between f of x and g of x, which area? This area. Okay, this area equals area under f of x, area under f of x, or between f of x and g of x, minus area under g of x. I think it is clear. So area under f of x is this region. Area of the g of x is this region. If you subtract from the black sheeted region, if you subtract the red sheeted region from the black sheeted region, you will find the yellow sheeted region. Okay, let's okay, that's okay. So this area equals area under the f of x is from a to b. This point is b. Sorry, from a to b f of x dx minus the area under g of x is from a to b integral g of x dx. You can write together these two integral. So this is f of x minus g of x dx. Okay, so this integral gives us the area between the two curves. Let's solve a small example. Find the area between the graph of f of x equals x squared minus 2x and x-axis. Okay, over in the indicated interval. Over the interval, let's write the interval. Actually, there are two questions in your textbook, but let's use the one of them. Minus 1 to 2, for example. Minus 1 to 2. Okay, so let's sketch the graph. You can sketch this graph easily by the first term idea. One intercept is 0, the other intercept is 2. And the shape like this one. So this is our graph. 0 to this point is 2. This point is 0. So A is minus 1. B is 2. Okay. So we should calculate this area. So for the first one, that area equals from minus 1 to actually this is positive when x from change from minus 1 to 0. Okay, so this area is minus 1 to 0. F of x dx is positive, but here function is negative. So from 0 to 2 plus from 0 to 2 f of x dx, that area, but this integral gives us the negative area, so this is minus. Okay, so we should write the minus here since f of x is negative. So maybe you can say that this is the area 1, this is the area 2, this is this area. So by calculating these integrals, you can find the area. So minus 1 to 0, x squared minus 2x dx, minus from 0 to 2, x squared minus 2x dx. You will observe this will be positive, okay? So this equals the integral of the x squared minus 2x is x cubed over 3 minus x squared, or x squared over 2, but 2 are cancelled. So we should this is antiderivative. We should calculate the differences of this antiderivative. We can use this notation from 0 to minus 1, or sometimes we use that notation from minus 1 to 0. Minus, this integral is the same, x cubed over 3 minus x squared from 0 to 2. So let's calculate these differences. For x equals 0, this is 0. 0 cubed over 3 minus 0 squared minus, for x equals minus 1, minus 1 cubed over 3 minus 1 squared. So this is the first differences, that one. For this differences, minus, for x equals 2 cube is 8, 8 over 3 minus 2 squared is 4, minus for x equals 0, this is 0. Okay, so let's conclude our result here. This is 0, this is minus 1, minus 1 over 3, plus 1, so this is 2 over 3, here minus, so minus 2 over 3. Isn't it? Yes, but this is negative. Cube is 1 over 3 minus plus. Where is the mistake? That's okay. That's okay. There's no problem here. Minus 1 over 3 minus, this is plus 1, so minus 1. Minus 1 over 3 minus 1 is minus 4 over 3. Here we have a minus, so this is 4 over 3. Okay, it should be positive because 4 over 3. And this one also should be positive with this minus factor. So this is minus 12 over 3. So minus 4 over 3. This minus, so plus 4 over 3. So as a result, that area is 8 over 3. I would like to make some explanation on this curve. Actually here, why we write the minus, I try to explain. This line is x equals, y equals 0 line. X-axis, this is x-axis, which is y equals 0 line. So here, in the first area, f of x is bigger than the y equals 0. Okay, this is y equals 0. So actually here, hiddenly, we write f of x minus 0. Okay, and in the second area, in this area, f of x is this function. So for y equals 0 is this function. So y equals 0 is bigger than the x squared minus 2x. So this area is from 0 to 2. 0 minus f of x, okay, dx. So you can consider this minus comes from the here, okay, because x is the above the f of x function. This is another viewpoint of the this fact. In this section, we have another important concept, income distribution, but I will record a new video to explain the income distribution because it is very important for your area.